Hi guys, hope you're having a great day. I just wanted to do a video on how the combustion engine has been optimized for power and fuel economy. So firstly, there are two types of fuel delivery, carburetors or fuel injectors. A carburetor's principal role is to mix air and fuel for the engine to combust. It has two parts. The first part is the bowl that contains a float in it to keep the fuel level constant. The second part is the venturi. It is a tube with a constriction in the middle. It uses Bernoulli's principle: when flow is fast, pressure is low. So when the tube constricts, flow is fast, so pressure is low, so it draws up fuel from the bowl via small pores. It's hard to adjust the ratio of fuel and air, which is one reason why they have been succeeded by the fuel injector. So, fuel injectors are a device for atomizing and injecting fuel into a cylinder. This occurs at a precise point, normally as the piston rises to the top of the cylinder. By atomizing the fuel, it increases the surface area, leading to a higher chance of complete combustion. Also, by controlling the timing of injection, we can reduce the chance of pre-ignition. The other thing that affects economy is transmissions. So there's three types of transmission, but two main ones: manual and automatic, which are made up of planetary systems and CVT. Transmissions supply power to the driveshaft and convert the high rev, low torque input from the engine's crankshaft into variable ratios of torque to speed. Most older cars are equipped with a manual transmission, which uses singular gears that lock together to create different gear ratios. They always must have a clutch to disconnect the engine output to the transmission. This is so the gearbox can change gear without being under load. However, when the clutch is pressed, the engine is doing work, but no power is supplied to the wheels. This decreases efficiency. The second type of transmission is the automatic planetary system. This uses a central sun gear that is orbited by planetary gears and a ring gear that goes round the outside of it all. By changing the inputs and outputs, you can change the gear ratios. But I won't be talking about CVT transmissions in this video. CVT transmissions are constantly variable transmissions and work off a set of pulleys that can squeeze together or separate. They are connected by a metal composite belt. As the pulleys squeeze together, the belt rides up the pulley, creating the effect of a larger gear. By increasing and decreasing the spacing of the two pulleys, it can create an infinite amount of gear ratios. Because of this, you can find the sweet spot for fuel efficiency between torque and speed. And because the gear ratios can be changed while under load, there is no need for a clutch, meaning less wasted fuel. Another adaptation is changes in the camshaft. Firstly, the camshaft is a lobed rod that is connected to the flywheel that controls the valve timing. Variable valve timing aims to have fuel economy and performance in a single engine. To do this, Honda created two different lobes on the camshaft, one larger lobe and one smaller lobe. When the smaller lobe controls the valves are open for less time. This has the effect that less fuel comes into the ignition chamber, and some spent exhaust gases do not escape after each cycle, which take up cylinder space, giving the effect of a smaller cylinder volume. All of this causes the engine to be less powerful and more efficient. However, when you put your foot down and want power, the larger lobes control the valves, causing them to stay open for longer. This means more fuel is ignited, creating more power. Also, all of the exhaust gases escape, giving the cylinder its full capacity so it can combust more fuel. This system was revolutionary, as cars can now be economical but also have the power when you want it. The next systems I'll be talking about are used to increase power. Firstly is forced induction. There are three main methods of forced induction: supercharging, turbocharging, and nitrous or NOS. Supercharging and turbocharging have little differences between them. However, they both rely on the principle that the more air you can shove in a cylinder, the more fuel you can combust and the more power you can get per stroke. Turbocharging uses the flow of exhaust gases to turn a turbine, which then pressurizes air, which is then forced into the cylinder. As the air is pressurized, it contains more oxygen, so more fuel can be burned. A supercharger does the same, but is powered by the crankshaft via a belt. The other method of forced induction is NOS. In a nitrous oxide system, nitrous is put into the cylinder rather than air. When the NOS becomes hot from being compressed, the oxygen breaks from the nitrogen and reacts with the fuel, causing combustion. Because NOS has a higher percentage of oxygen than in air, there will be more oxygen in the volume of NOS compared to air. Thus, more oxygen in the cylinder means more fuel and so more power. So you might be thinking, why not use pure oxygen? Firstly, oxygen doesn't liquefy under pressure like NOS, so you would need lots of storage to hold the oxygen. And secondly, as Barney Navarro found out, the mixture of pure oxygen and fuel is highly volatile and is likely to cause pre-ignition, which means the fuel combusts before the piston is at its highest point. Or as Barney Navarro found out, it caused detonation of his engine, which made his engine act more like a bomb than a car. The other optimizations for fuel efficiency or power could be aerodynamics to increase fuel efficiency, the chassis material, for example, making cars out of carbon fiber, regenerative braking, which electric vehicles use, and cylinder compression ratios to increase the efficiency of combustion.